Watch this battery finish charging outside Brisbane. Blink and you'll miss it. A rover on Mars just read something in 3 billion-year-old clay it wasn't built to expect. On a warehouse floor, a robotic arm stopped mid-motion and rerouted a box. Nobody told it to. And somewhere close to you, a locked box already holds a signal nobody's opened yet. At a clinic in the Midwest, a screen just caught a shadow no doctor could see yet. 5 signals, 5 real places, none of them a headline yet. Here's the rule underneath all 5. Progress isn't a headline, it's accumulation. Real labs, real names, real dates. You'll hear every one, and you can check them yourself. Start with the one closest to a lab bench, a battery that charges almost like a thought. 5 real signals, and the last one is already sitting inside someone you know. That's the last locked box for now, because the next signal doesn't hide in a person, it hides in a battery. Outside Brisbane, a small team just charged a lab cell almost as fast as they plugged it in. The lab is part of a university energy program, and the run was logged this past spring. Charging a battery is really just herding ions through a wall, fast enough that the wall doesn't crack. Push too hard, and that wall gets hot, and heat is what slowly kills every phone battery you've owned. This cell barely warmed. The team swapped the wall's material, not its shape. Ions moved through it in a coordinated rush instead of a scramble. Nobody in that room cheered. They just checked the numbers twice. Scaled up and proven safe, this chemistry could mean a phone charging fully on your walk to the kitchen. It's still years from your pocket. A single successful cell isn't yet a factory line. That same quickness just turned up somewhere nobody thought to look. On another planet. 200 million miles away, a rover had been drilling into a Martian riverbed for the better part of a decade. In March of 2026, its chemistry instrument flagged something in clay from a dry lake bed named for an Earth canyon. Not a fossil, not a footprint. A single organic molecule folded into 3 billion-year-old clay. Its shape is close enough to a building block of Earth biology that 2 chemists checked the math 3 times. Nobody in that room called it life. A molecule this size can form without anything alive nearby. Comets carry it. Volcanic vents cook it up on their own. So the honest answer is the hardest one. Maybe, and not yet. The find wasn't luck. The instrument was roughly 10 times more sensitive than the last rovers. The same climbing sensitivity that charged a battery in a blink is why this molecule didn't stay invisible. And the instrument that caught it has a close cousin already at work back on Earth, watching over boxes on a warehouse floor, which brings the same instrument family somewhere far less romantic than Mars, onto a warehouse floor. A cardboard box rides the belt toward the arm, one corner already split down the seam. Nobody typed a rule for a split corner. The arm paused, then rerouted the box on its own. The gripper light flashed amber once, and the box was already gone to the side rail. At a distribution center outside Columbus, Ohio, engineers built that pause in early 2025. A small onboard model reads pressure, shape, and vibration together, not one sensor, a pattern across 3. Same threshold as the rover. Same threshold as the battery. Now it's wearing a hard hat. Not a Jobs panic story, a system under pressure to never miss a package again. One major retailer reported the error rate on flagged packages dropped by roughly 2/3 after rollout. A battery, a smear of clay, a cracked box. 3 machines built to notice what a person would have missed. That same noticing just moved somewhere far more personal. Inside a vein. In Rochester, Minnesota, a routine blood draw goes somewhere most blood draws never go. An algorithm reads the plasma for tumor DNA fragments shed years before a mass shows on any scan. In one pilot cohort, the flag showed up roughly 3 years before any imaging would have caught it. 3 years is time a scan alone cannot give you. Dr. Kessler leads the trial, and she is careful with every word she uses about it. This is early research, she says, run inside a multi-year trial, not a diagnosis from one test. No scan, no symptom, just a pattern in the noise. One woman's flag came on an ordinary Tuesday, months before she felt anything wrong. Treatment started sooner because a pattern hunter caught the shadow before the shadow caught up with her. That locked box from the start of this video was never a stranger's story. It was a signal like this one, sitting quietly in someone you already know. None of it, battery, clay, warehouse, this vial, ran on hardware sitting on those benches 10 years ago. None of that hardware 10 years back could have carried what you just watched. In a research clean room outside Leuven, Belgium, engineers built a chip that thinks where its memory already sits. Ordinary chips keep memory and processor apart, shuttling data back and forth constantly. This new architecture skips the commute. The math happens inside the memory itself. Engineers there measured roughly a 10-fold drop in energy for exactly this kind of pattern matching. Same pattern matching a battery lab runs. Same kind a rover runs, a warehouse arm, a blood draw. One quiet shift in silicon sitting underneath 4 separate discoveries. None of this makes the battery, the clay, the warehouse, or the blood test any less real. It just means the foundation was never a mystery. It was a decision made in a clean room, on purpose. But energy is only half the story. What all 5 scenes add up to is still one thread waiting to be pulled tight. Every one of those 5 scenes was quietly waiting on this same chip to exist. 5 labs, 5 teams who've likely never met. One shared, unglamorous engine underneath. So go back to the beginning with me. 5 questions, asked before you knew any of their answers. Outside Brisbane, a battery closed a charge cycle almost as fast as it opened. A material finally caught up. In a Martian clay sample 3 billion years old, an instrument found a molecule shaped like a distant cousin of life's own alphabet. Neither was an accident. Both were instruments finally sensitive enough to notice. That noticing didn't stay on a warehouse floor for long. It moved into a vein. A clinic algorithm found a cancer shadow 3 years before any scan. And that shadow, remember, was never a stranger's. It was the signal already sitting in someone you know, waiting for a routine draw to find it. 5 signals, 5 real teams, 5 dates you can look up tonight. That was the promise. That's the count. Here's the rule, plainly. Progress doesn't arrive. It accumulates until one ordinary day it reaches you. The future isn't a single headline. It's 100 quiet Tuesdays in a lab until one of them reaches you. If you've ever waited days for a test result to come back, tell us, what would it have meant to know 3 years sooner?